Question number 18, a uniform meter rule of mass 100 grams. So if you remember what I said, whenever you have a meter rule, so you start by drawing a line, right? Initially you mark the point 0. It's a meter rule means 1 meter. So here will be 100 centimeter mark. Then you mark the middle with 50 of mass 100 gram. So we know that the mass always acts at the center. So here you will have the mass 100 gram is balanced on a fulcrum at 40 centimeter mark. So here was the fulcrum at 40 centimeter mark by suspending an unknown mass m at 20 centimeters. Obviously, if the fulcrum is here, the weight is acting from this side. So this contributes to the clockwise movement. So we will need something that balances it out with an anti-clockwise movement. So the mass was m and it was at 20 centimeter. So since we're done with question number 1 and 2, just tell me the answer for 1. What was the unknown mass?
50 grams.
50 grams. Okay. And number 2, what was the answer? To which side the rule will tilt if the mass m is moved to 10 centimeter? What was the answer for that?
Can you redo this question? I don't understand.
Okay, sure. So then let's start with question number 2 only. Now see, the question is something like this. This is the balanced beam. It is balanced, right? Why is it balanced? What is the necessary condition for anything to be balanced? More precise? From the both sides, right? That is the clockwise torque must be equal to the anti-clockwise torque. Yes or no? Now you tell me, if I shift this mass on the 10 centimeter mark, so here, all right? So on this side, what is happening? The distance is increasing. If the perpendicular distance increases, what will happen to the torque on this side? It will? Sorry? Somebody is saying decrease. Raghav? No. Fulcrum is basically a fixed point about which the beam is resting. Okay, imagine this is the beam and you keep it on top of this, right? So it's resting on top of this. So this will be the fulcrum. Okay, that's one. Number 2 is the torque is directly proportional to the perpendicular distance. Higher the perpendicular distance, higher will be the torque. So if you shift it on 10 centimeter, obviously the perpendicular distance will increase. That will increase the torque. That means, won't this torque be more than this torque, right? The anti-clockwise torque will be more than the clockwise torque. So naturally it will tilt in the anti-clockwise direction. You got it now, Zishan? Okay. So we can write here, since the anti-clockwise moment increases due to increase in perpendicular distance, the rule will tilt in the anti-clockwise direction. So let's see question number 3 now. So question number 3 is asking, what is the resultant moment now, right? That means it's asking what will be the resultant moment in this new situation. So how do you find the resultant moment? Okay. So let's first find the clockwise moment. So clockwise moment will be due to what? It'll be due to this mass, which is 100 gram. So it'll be 100 into the perpendicular distance is this, so 10. So it'll be 1000 gram force centimeter. Now, since it is clockwise, it is going to be negative. Then let's find the anti-clockwise moment. So calculate and tell me what will be the new anti-clockwise moment if you shift the mass to 10 position, 10 centimeter mark. So the anti-clockwise moment will be 50 multiplied by 30. So it'll be 1500 gram force centimeter. Since it is anti-clockwise, it's going to be positive. So therefore, what will be the resultant torque? Resultant torque will be the sum of the two. So this plus this. So it'll be 1500 minus 1000. So it'll be 500 gram force centimeter, and it's also going to be anti-clockwise, so positive. Yes, Tanya. Which part are you having problem with? From part 2. It's something like this. See, imagine this is the beam, right? And it has been balanced because there is a mass hanging here. No? How do I explain? Okay, something like this. Okay, something like this. Imagine this is the beam and it has been balanced because I kept a heavy mass on this side. Okay, so it has been balanced because why? The anti-clockwise torque must have been equal to the clockwise torque. I'll go a little bit behind. Why is it balanced? Because the anti-clockwise torque is equal to the clockwise torque. Yes. Now, if I shift this mass to this side, then you see the force that is due to the weight of this remains the same. But now the perpendicular distance has increased. Can you see that? Before it was this much. Now that you have shifted it here, it has increased. You got that? Now we know that if you increase the perpendicular distance, then the torque on this side will also increase. That means the torque on this side will now be more than the torque on this side. So naturally it will turn anti-clockwise. You get it? And we have calculated that also. So now it will be 500 gram force more. Okay. So we calculated the resultant moment. Now it is asking number 4. How can it be balanced by another mass of 50 gram? Where should I place it so that it gets balanced again? First, let's clarify that. Where should I place it? Should I place it towards the, for you it will be right, left. Should I place you towards your left or should I place it towards your right? What do you think? That makes sense, right? It's already rotating this side. So if I want to stop that rotation, I need to put it here, right? Okay. But where? I don't know where. So what I'm going to do is I'm just going to imagine that I will be placing the next mass here. Okay, let's call it M3. We already have so many masses. This mass is of 50 gram. This is clear. Why are we putting on the right? Okay. Now let's say that we are putting on the right and let's assume that we are placing it at a distance X. Okay. What distance? I don't know. So let's say that we place it at X. Okay. So if you place it at X, you tell me one thing. What should be the torque made by this mass so that it gets balanced again? What should be the torque? See, again, why was it not balanced? Let's start from there. Why was it not balanced? When you shifted the mass on this side to the green line, why did the ruler tilt? Yes? Exactly. The anti-clockwise moment was more than the clockwise moment now. But how much more was it? 500. So this is the reason why it's rotating anti-clockwise, right? So I need to place the mass m3 in such a way that it balances out the additional torque, right? So that means, therefore, the m3 into the perpendicular distance must be equal to this additional 500 gram force centimeter. Okay, since on this side it is more, we have to add this in such a way that whatever torque this mass produces, it's exactly equal to the extra torque. Okay, so now let's equate it. So m3, we know that it's 500 gram. Perpendicular distance is x is equal to 500. If you do the basic math, this gets cancelled, you get 10 centimeter. Therefore, 50 gram must be placed at 50 centimeter mark. So it should be 10 centimeter away from the fulcrum. So if it is 10 centimeter away from the fulcrum, means we have to keep this mass here. The diagram in the figure 1. Okay. What is this? Oh, uniform meter rule. Okay. So let's draw a uniform meter rule. So as I told you, always mark the 0, 100 and 50. Okay. And its weight is 100 gram force. So you also draw its weight. Pivoted at its center O. So it's pivoted here only at its center, wherever its weight is acting. Two weights, 100 GF and 250 GF, hang from the point A and B as shown. Okay, so the point A, we have a weight that's downward, and at B also we have a weight that's going downward. On this side we have 150 gram force, and on this side we have 250 gram force. They have not told us at what point. Okay, they have. Hang from points A and B respectively on the meter rule such that OA is 40. Such that, this is the point O, OA is 40 centimeter and OB is 20 centimeter. So OB is 20 centimeter. That's it. So question number 1, calculate the anti-clockwise moment. So Raghav, the anti-clockwise moment will be due to which force? 150 or 250? 150. Very good. 150 will create anti-clockwise moment. So it'll be 150 into, and what is the perpendicular distance, Raghav? Very good. Then you got it. 40. So 0, 0 will be 00. 4 5s are 20. 0 carry 2. 4 1s are 4. 6000 gram force centimeter. Then number 2, clockwise movement. Will be equal to 250 into the perpendicular distance is 20. So 25 into 2, 50, 00, 5000 gram force centimeter. What is the difference between the anti-clockwise moment and the clockwise moment? Why is it so easy? Anti-clockwise will be positive, clockwise will be negative. Number 3, what is the difference between anti-clockwise and clockwise moment? So required difference. When we have to find the difference, we don't take the sign into account. So 6000 minus 5000 will be 1000 gram force centimeter. then the distance from O where 100 GF should be placed to balance the meter rule. So now you tell me, if we got the difference to be 100 gram per centimeter, is the ruler balanced or unbalanced? At this situation, will the ruler be balanced or unbalanced? Unbalanced. Yes, good DJ. Why will it be unbalanced? Very good. Because the anti-clockwise movement is clearly not equal to the clockwise movement. So, in order to balance it, we need more clockwise movement. So, we need more clockwise movement means we need to put a weight here. So, let's say that we place another 100 gram force here. Okay, at a distance of x. So number 4, let 100 gram force be placed at a distance of x from the fulcrum towards the 100 centimeter mark. You also have to mention like which way you are putting. Are you putting on this side or are you putting on that side? So I'm saying that we are putting it towards the 100 side. Okay, on the 100 side. Then, therefore, so that means what? That means the torque that this 100 gram force generates must be equal to this additional torque, right? So that means 100 gram force into the distance is x must be this extra torque that was causing the ruler to tilt. So it will be 100 into x is equal to 10,000. Do you get this? Yes? Yeah. See, we got an additional difference of 1000. Yes or no? So we need more of clockwise movement. Yes. How much more do we need exactly? On this side we have 6000. Let me just write it down. On this side we have 6000. On this side we have 5000. So how much more do we need on this side? We need 1000 more. So this 1000 torque has to be created by this weight. Yes or no? So we are saying the distance is x. So that means 100 into x must be equal to the additional 1000 that we need. You got it? Okay. Then if you solve this, you get x is equal to 10 centimeter. Therefore, the 100 gram force must be kept at 60 centimeter mark.
60 centimeters.
See, here we're just being precise about where to put it. I'll tell you why we are writing it like that. The reason is when you write, it should be 10 centimeter away from the fulcrum, no? 10 centimeter can mean towards the right also. It can mean towards the left also, right? So to avoid that confusion, is it towards the left or is it towards the right? We precisely say that it should be at 60 centimeter mark. So now there is no confusion that it should be on this side or this side. We know that it must be on this side. Okay. How 60 you got? How we got 60? Yeah, because it should be 10 centimeter away from the fulcrum, and 10 centimeter on this side means you'll end up getting in 60.
Yeah.
Yeah, teacher.
Sir, if you have to like make it equal, then make it equal by like reducing the length in the other side, left side. Instead of increasing the width. Yes, not.
Yes. What we can do is, instead of adding an additional weight on a certain distance, what you can do is you can shift the 250 on that side. Okay, if you shift 250 towards the 100 centimeter mark, then there will be a point where the torque created by this 250 will be equal to torque created by the 150. Okay, it's like how we play seesaw. If you're playing seesaw with a let's say your younger sister, right? Then what do? You try to keep her as far as possible and you try to sit as near as possible so that the torque balances out. Since you are heavy, so force is more, so we decrease the perpendicular distance.
This point A towards the so you
We assume let this distance be x. Okay, so that's a good question. We assume that because this type of question also they come. We assume that this distance be x, so it will not be 20 anymore. Then what will be the anticlockwise torque? It will still remain 40 into 150 into 40. Do you get it? The anticlockwise torque will still remain that. But since you are shifting this on, let's say, the right side, now the weight is 250 multiplied by x. We don't know what is the distance. Then you can solve this and get the value of x. Once you have x, that means that's where, if you keep it, the anticlockwise moment will be equal to the clockwise moment. Okay, that's a good question. Be very careful here, okay? Read the question very well. It's very different from the question that we have done. Let's see if anyone can point out why. Very good. Here they're saying that it's a half meter rule. It's not a meter rule. Half meter means how many centimeter? 50. So what will be on the extreme left? 0. What will be in the extreme right? Now it will be 50. And what will be in the middle? Very good. You guys are very smart. Draw. A uniform half meter rule. So the moment I see a uniform half meter rule, I'm going to draw a line, mark 0 here, mark 50 here, and right in the middle we have 25. Okay. What you can also do is you can draw its weight acting downward from the center of gravity. Okay. So the weight of the ruler is not given. This you can consider to be your introduction, the starting part. Now a uniform half meter rule can be balanced at 29 centimeter mark. So that means it's being balanced here. Wherever it is being balanced, that is the position of your fulcrum. Okay? Okay. Till here most of you got it. Now see, when a mass of 25 gram is hung, imagine that part is not there. Look at this ruler. Do you think it will be balanced at this point? Okay, imagine the question is over. Till here, if the question was given, do you think it is going to be balanced? No. Why not?
if the tops on both sides will be different, so that was one side to be treated.
Exactly. We know that the torque on this side, because of the weight, it's not going to be balanced. And this side, we don't have any weight only. So definitely it's going to tilt anti-clockwise. Yes. So that's why they're saying that 20 gram is hung from one of its end. Now Raghav asked a good question that, okay, 20 gram is hung from one of its end. Should it be on this end or should it be on this end? If it is on this end, will it balance? No, it will further increase the anti-clockwise moment and maybe the rule will tilt faster, right? So it definitely must be kept here. So here will be your mass of 20 gram. You got it, Raghav? If we want to balance both sides, we need to have a weight. So draw the arrangement, done. Most of you could do this. Some of you are missing the weight or some of you are missing the mass. Okay, finished. Good. So draw the diagram, done. Find the mass of the half meter rule. So since it is balanced, okay, let's just write let the mass of the rule be W by principle of moment. The anti-clockwise moment must be equal to clockwise moment. So the anti-clockwise moment is due to W. So it's going to be W into the perpendicular distance. So Elena, can you tell me what is the perpendicular distance here for W? Yes. At what distance is W from the fulcrum? Very good. 4. And the clockwise moment is due to 20. And at what distance is it? Very good. 50 minus 29. So 21. Okay. Then you can easily solve this. We get W is equal to 4 5s are 25, 105. Let's see question number C. In which direction would the balancing point shift if 20 gram mass is shifted inside its one end? Right? What does that even mean? Let's try to understand. They are asking in which direction would the balancing point, means where you keep the fulcrum to balance it, it will shift if you move this 20 gram mass is shifted inside its one end. That means if you shift this side, if you shift this mass on this side, which way will the balancing point shift? What do you think?
Towards the zero mark.
Okay, towards the zero mark. Why towards the zero mark, Tanisha?
Because since the mass is like coming inside, so the perpendicular distance is like reducing. Yeah, it's basically reducing. So but if shift to again increase the.
Yeah, very good. So what she's saying is, if you move the mass on this side, okay, imagine that this mass is no longer here and the mass is here. So notice that if you move the mass on this side, the perpendicular distance has reduced. So if the perpendicular distance has reduced, that means the clockwise moment will also reduce, right? And this side we're not doing anything. So if you're not doing anything here, the anti-clockwise moment will remain same as it was, but the clockwise moment will reduce, right? In that case, it will not be balanced. So to compensate for that, to compensate for the reduced distance due to moving the mass, what we do is we also move the fulcrum to this side. So if you move the fulcrum here, then the distance will now increase, so that will compensate for the reduced torque. Got it? Okay. Let's see how do you write it. Since the perpendicular distance will decrease, the fulcrum, that is the balancing point, must be, oh, not must be, will be shifted towards 25 centimeter mark. Okay, I just have one thing. Please don't write fulcrum. Okay, since the question is asking balancing point, you write balancing point only, because the fulcrum cannot shift on its own. The balancing point will shift. Okay. Okay.